Hey folks, this is a video on some of the identities that we're going to be using in this section. Before I get into the identities though, I'd like to talk about the math that is going to be used in this section. All of the math that you're using is old math. We're just applying it to some new concepts in trigonometry. The first type of math that you're going to use is substitution, and we are going to use this a lot. Secondly, you are going to be adding and subtracting fractions. Remember that you do this by getting a common denominator. Next, you will be multiplying fractions. We've done this a good bit even in our semester so far. And remember that multiplying fractions, you have to multiply the tops and multiply the bottoms. Next, we will be dividing fractions. We've definitely done this a good bit. Dividing fractions is going to be done by multiplying by the reciprocal. And then the last thing that we'll be using is the order of operations. So as you can see, all of this is old math. We have been doing this already. It's just something to pay attention to in our trig. Now let's look at the first set of identities. These identities you have already seen as well in the last chapter. We know that cosecant of theta is going to be equal to 1 divided by the sine of theta. These are called quotient identities. I think that's probably obvious because we're using quotients here. Secant of theta is going to be 1 divided by cosine of theta. Tangent of theta, we've talked about tangent in several different ways, opposite over adjacent, the y value over the x value, but the one that I want to use here is sine of theta divided by cosine of theta. Cotangent is going to be 1 divided by the tangent of theta, but because it's the reciprocal of tangent, we also know it's going to be the cosine of theta over the sine of theta. Just some notation issues to be aware of. You're going to start seeing sine squared of theta, and what this means is you're literally taking the whole entire sine of theta and you're multiplying by the sine of theta. Another way that you could have written this is the sine of theta in parentheses squared, but that's not how we write it. When we write it, we're going to put that square. It looks as though we're putting it on the sine, but that's technically the entire sine of theta. What you need to understand most of all is that you see that I have written here sine of theta squared. This is not the same thing. This is actually where I'm only squaring the theta part of it, not the sine of theta. So just understand the notation so that we can go into Pythagorean identities, which is next. I have 3 basic Pythagorean identities. The first one here that you can see is the sine squared of theta plus the cosine squared of theta is equal to 1. The second one, 1 plus the tangent squared of theta is equal to the secant squared of theta. And then thirdly is going to be 1 plus the cotangent squared of theta is equal to the cosecant squared of theta. These are our 3 main Pythagorean identities, but there's also ways that we can rearrange them and look at them differently. I'm going to do one of these, and you're going to find the other 5 for your embedded question to bring it to class. So the first way that I could rearrange, notice here that I've asked you to rearrange so that you can get sine squared of theta alone. And we understand that by doing this, if sine squared is to be alone, that means that the cosine squared needs to be bumped to the other side. And we know that we're going to do that by subtraction. So sine squared of theta is equal to 1 minus the cosine squared of theta. So you'll notice that for each of these Pythagorean identities, there is 2 ways to rearrange. I've done the one for the first one, and so you are to find the other 5 ways to rearrange each of those 3 identities and bring those to class to turn them in.